How to find in which individual assets we might have problems in just 2 minutes. Let's go. So we start the analysis by loading a Parquet file. By checking here limit data attributes, we can now dynamically filter huge Parquet files by the columns that we want to keep. So let's add wind turbine name and filter and select averages. Here we now have 4 identical assets, in this case wind turbines, which are located actually not far from each other. The colors here indicate where levels of tags differ among the assets. As this is now 4 years of data, let's filter to the most recent 3 months of operation first, and only then select and compare the assets to each other. Now our algorithm compares the distributions of the assets for all variables and the combinations of variables to each other. So here we get now a nice list of variable combinations, which is ordered by how well the distributions are separated. This now reveals, for example, that here the blue windmill actually has anomalous gearbox temperatures. Let's now select such situations across all assets by a graphical lasso and switch to another variable. For example, let's go for wind speed. Here you can now see that the anomalies start to occur at wind speeds larger than 5 kilometers per hour. Of course, we can now also drill down further to quickly inspect other anomalies, such as negative reactive power. If we now click here at the table, we can also see the underlying data model with the asset names and the respective variables as columns. So you see it's very easily possible to analyze time series across multiple assets, in particular to compare the operations to each other to find out anomalous operating conditions in individual assets.